Now we're going to look at the conservation of energy. Now, what is the conservation of energy? The conservation of anything is when you keep something or you try to keep it the same. There are many different forms of energy: kinetic energy, sound energy, thermal energy, light energy, and so on. Each form of energy can be transferred or converted into another form. This is the conservation of energy. And it basically says this: energy cannot be created or destroyed, it only changes form. This means that energy never just disappears. The total amount of energy always stays the same. In other words, the total input energy is equal to total output energy. And if it isn't, it means that some energy has been wasted somewhere, but nevertheless it's still being turned into some form of energy, usually heat. So in most energy transfers, the energy is transferred to several different forms which may or may not be useful. Now we're going to look at the energy transfer of roller coasters, in particular from gravitational potential energy into kinetic energy. Let's start this. Play. Watch this. Now that happens ever so quickly. What we're interested in is what happens to the potential energy and the kinetic energy at different parts of the ride. Let's go back to the beginning. Now, right at the very top, it's moving very, very slowly, and it has a large height. So let's find out what these values are. The height is 50, the velocity is 2, which is very slow. Notice that it's got a large height, so mgh is very high, so it's got a large value for 250. It has a large value of 250,000 joules. Notice only 1,000 joules of kinetic energy because it's moving so slowly. Now what happens as it moves and comes off the edge? Look what happens to gravitational energy and the kinetic energy. As it gains kinetic energy, it loses gravitational potential energy. So when it's at the bottom part, all that potential energy or almost all that potential energy has turned into kinetic energy. So that's when it's moving the fastest. Notice it's moving at over 30 meters a second here, and it's at a height of 1 meter. Then what happens? It moves up again, and that kinetic energy is turned back into potential energy, although it's not at the same height as it was before. So there is a little bit of kinetic energy left. In fact, it's going at 20 meters a second now, but it's at 30 meters height. Then it drops down again, and that potential energy is turned back into some kinetic energy. At the bottom, the velocity is 28 now. It's quite fast, but not as fast as it was right at the very bottom because it's still at 10 meters height. Then it goes up to this height, back into potential energy again, and into little kinetic energy. It's only going at 14 meters a second now, which is somewhat slower. And then right at the very end, it loses potential energy and gains kinetic energy as it goes. So let's run that again, shall we? So notice how the velocity changes. Now you might have to do a problem relating to this. Potential energy is turned into kinetic energy. So what is the velocity at the lowest point? At the top, all the energy is gravitational potential energy. So let's calculate what that is. Find the gravitational potential energy at the top. The height is 45 meters, the mass is 500 kilograms, V is equal to 0. We know that the gravitational potential energy is equal to m times g times by h. M is 500, g is 10, h is 45. So we multiply those together and we get a gravitational potential energy of 225,000 joules. What is the kinetic energy at the top? Well, all the energy at the top is gravitational potential energy, and there's no kinetic energy because it's not moving. Velocity is 0. Now at the bottom, it's swapped around. That gravitational potential energy has turned into kinetic energy. So the height is now 0. The mass is still 500 kilograms. The gravitational potential energy is mgh, which is 500 times by 10 times by 0, which means that the gravitational potential energy must be 0 because anything multiplied by 0 is 0. But all the energy that was gravitational potential energy has now turned into kinetic energy. Now, the gravitational potential energy lost is equal to the kinetic energy gained. So at the bottom of the ride, all the energy is now kinetic energy. So that kinetic energy is what the potential energy was before, 225,000. Now the gravitational potential energy is equal to 0. Kinetic energy is 225,000. It's equal to half mv squared. Let's substitute the values. M is equal to 500. V is equal, we need to find that out. We know the kinetic energy is 225,000. So let's simplify this to find the V squared. Divide both sides by 250 and we get V squared. This is V squared. V is the square root of 900, which is 30 meters per second.